Hi, everybody. Thanks for joining me. Up until this point, all of my videos have covered Indiana seventh grade standards. And while I am a seventh grade teacher, I also have the seventh grade advanced class. And after we complete all those seventh grade standards, then we start in on the eighth grade book. So this is the first section that I'm recording a video for on eighth grade standards. We are going to look today at scientific notation. So right now, we're not going to do operations with scientific notation yet. We'll do that later. We are just going to focus on converting back and forth, starting with standard notation, normal numbers, and writing them in scientific and vice versa. When you're starting with a normal number in standard form and you want to write it in scientific notation, the easiest thing to do is to follow these 4 steps. Step number 1, we're going to write all the non-zero digits. Non-zero, if you've never heard that before, it's exactly what it sounds like. It's the numbers that are not zero. The only time you're actually going to write a 0 is if he's trapped in between other numbers. And if he's trapped in between, he just travels right along with them. Step number 2, you put a decimal point after the first number. It always goes in that same place. Step number 3, you simply write times 10. Step number 4 is the only step that takes any kind of brain power. You have to find your exponent. To find your exponent, you're just going to count moves. And I'll show you all this in several examples, but you're going to count from your new decimal where you put it to the old decimal where it originally was. You count new to old. You spell the word no. So let's try one. Our first number here is 5,280,000. So step 1, I'm going to write those non-zero digits. So I'm going to write 5, 2, 8. The zeros there at the end are not trapped in between any other numbers, so they do not get included right now. Step number 2, I put a decimal point after the first number. Step number 3, I write times 10. Okay. Now I'm going to go back up to that original number that I had, the 5,280,000. I'm going to make a note where I put the decimal. I put it right here after the 5. Oh my goodness, it's already going to start not writing. I barely even started and it's already going to be a pain. I'm going to put an N underneath that, N for new. And you don't have to literally do this. You can just think through it. Now, the old decimal, if you don't see it, then he's hiding at the end. So I'm going to put that there, and I'm going to put an O for old. I count new to old. I spell the word no. It takes me 1, 2, 3, 4, 5, 6 moves. And I was traveling to the right. That's in a positive direction. So my exponent is a positive 6. That exponent does not represent how many zeros. That's a common mistake. The exponent is how many moves, not how many zeros. Let's do another. 7,100. I'm going to write the non-zero digits, so just the 7 and the 1. I'm going to put a decimal after the first number, and I'm going to write times 10. Those first 3 steps, honestly, they don't take much thought. Now I'm going to go up to that number. I'm going to put the decimal where my new one is. I wanted it after the 7. So I'm going to stick it there and put N for new. The old one, if you don't see it, was hiding at the end. I'm going to count new to old, spell the word no. It takes me 1, 2, 3 moves. Again, I was traveling to the right. That's a positive direction. So my exponent would be a positive 3. Let's do another. 400. Now this one's a little bit weird because when I write my non-zero digits, I only have one number to write down. I just put a 4. Some people will go ahead and put the decimal after that. I don't like it though, because saying 4 point just sort of bugs me. Nobody says that. You wouldn't say I have $4. You would just say 4, right? So I'm just going to put 4. And then I'm still going to write the times 10. I'm going to use the same process to find my exponent. Here's where I put it. This is my new one. I don't see one, so that means the old one was invisible, hiding at the end. It takes me 1, 2 moves to the right. Count N to O, spell no. 2 moves to the right, that's a positive direction, so that's a positive 2. The next one's kind of different too, because I already have a decimal that I see in there. but the process is the same. Everything that I described to you is going to be the same way that I've described it for the first 3 examples that we've done. So I write the non-zero digits. This time, though, I do have a 0 that's trapped in between others. So he does travel along with them. So I'm going to put 3, 0, 1, 2, 8. It looks strange, but they're all non-zero digits with the 0 trap. So they all get written down. I still put a decimal after my first number. I still write times 10. So go up to your original number. Here's where I put it. This is the new one. The old one was right here. When I count new to old, I'm not going to count all the way to the end of the number. I'm just going to count from the new decimal to the old decimal. It takes me 2 moves to the right. So like the problem I did before, this one also gets an exponent of a positive 2. Well, so far, the ones we've done have all had positive exponents. They're not always going to have positive exponents, though. All the ones we've been doing have been whole numbers, which, by the way, saying whole numbers makes me think of one other thing I'd like to show you. I'm going to go back for a minute. If any of these happen to be negative, like if this had been a negative 301.28, the only thing I do different in my answer, you ready for this? It's really, really difficult. It's going to blow your mind. I put a negative in front of the 3. Mind blown, right? If it had been a negative 400, I just would have put a negative in front of the 4. It doesn't mean you're going to count backwards or do anything different. You just stick that negative sign in front. Okay, so what I was saying before I remembered I wanted to show you that, I'm still going to follow the same process. It's just when I count new to old on my decimals, what you're going to see is that I'm counting backwards. I'm counting in a negative direction. So I'm going to end up with a negative exponent. That's what makes it less than a whole number. That's what makes it a decimal or part of a whole instead of something bigger. So on the first one here, non-zero digits, 6 and 7, no zeros are trapped in between. Decimal after the first, write times 10. Now here's where I put it. This is my new one. The old one was here. I'm not counting to the end of what I see. I'm counting to where the decimal used to be. It takes me 1, 2, 3 moves to the left when I count new to old. I'm still spelling no, but I'm spelling it backwards. So instead of putting a positive 3, I'm going to call that a negative 3 for my exponent. Let's try the next one. Non-zero digits would be 285. Decimal after the first, write times 10. Okay, go up to your original number. Here's where we put it. This is the new one. Here's where the old one is. I'm going to count new to old. Spell the word no. 1, 2, 3, 4, 5. But I spelled no backwards. I moved to the left. So instead of a positive 5, it's a negative 5. Let's try one more of those. Non-zero digits would be 34. Decimal after the first, write times 10. Go up to your original number. Here's where I wrote it. This is the new. Here's where it used to be. This is the old. It takes me just 1 move to the left. I spelled no backwards, so that's a negative 1. It's really, really important to remember that the exponent is the number of moves. It's not the number of zeros. In the many, many years that I've taught this, the most common mistake I see happen on my students' papers is that they think the exponent is zeros. It's moves, not zeros. Okay? So that's changing from standard to scientific. In my opinion, it's a little bit easier to go the other way. When I want to convert from scientific to standard, I'm going to pick up the decimal and I'm going to move it however many my exponent says to move it. If the exponent was positive, it's telling me to move right. If my exponent was negative, it's telling me to move left. The last thing that I want you to do is rewrite your answer so that it's nice and neat and easy to read. You'll see that when I move mine, I do these little loops down below and I fill in gaps with zeros. You need to rewrite it so that you don't have any little loops or markings to yourself. You don't want to have the old decimal in there. You only want to have the final one where it lands. So it's really important to clean up your answer. I really think you're going to find this part pretty easy. 3.8 times 10 to the fourth. My exponent is a positive 4. So what that's telling me to do is pick up my decimal and go 4 to the right. 1, 2, 3, 4. Fill in any of those blank little loops or gaps you have with zeros, and then rewrite it. So I have a 3, 8, 0, 0, 0. Now in my class, I'm not a stickler on commas. I really don't care if you have them or not. Commas don't make the number. They make a number easier to read, but they don't make or break the number. If you are going to put commas, make sure you put them in the right place. Commas and decimals are not the same thing. If you want to go ahead and put a comma here, this would be 38,000, and that's totally fine. Make sure when you write your answer, you don't have these little loops anymore. And this decimal after the 3 is absolutely gone. It's not there anymore. Don't rewrite that, or you haven't actually done the work. The next one says 6.014. My exponent's a positive 6, so it's telling me to go right 6. So I'm going to pick it up and go 1, 2, 3, 4, 5, 6. Fill in all those gaps with zeros, and now rewrite it. So I have 6, 0, 1, 4, 0, 0, 0. If you want to put commas in, you can. I end up with 6,014,000. The decimal that was after the 6 is no longer there, and I rewrote it so that I didn't have all those nasty little loops. Remember, your exponent is how many moves. It doesn't mean there's going to be 6 zeros. It means there's going to be 6 moves from where the decimal used to be. 1.2738 times 10 to the second. Now, this is kind of a weirdo one because you won't always end up going past where your numbers end. You won't always have to add on zeros. This time, I don't even get to where the numbers end. Positive 2 for my exponent means pick it up and go 2 to the right. So 1, 2, lock it in, rewrite it. My new number is 127.38. 5 times 10 to the third. Well, if I don't see the decimal, that means it was hiding at the end. 3 for my exponent means 3 to the right. 1, 2, 3, fill them in. So 5, 0, 0, 0. This was 5,000. If your exponent's negative, what do you think you're going to do differently? Hopefully you said move left. Positive, I move right. Negative, I move left. So exponent of negative 3, I'm going 3 to the left. Pick it up and scoot, scoot, scoot. 1, 2, 3. Lock it in. Fill in the gaps. Rewrite it. 0.00755. That decimal that used to be after the 7 is not there anymore. You picked it up and you moved it. Now, if you want to call this 0.00755, that's fine. Those are completely the same number. If you're not one of my students and you just happen to come across this, you might just ask your teacher which they prefer. For me, it truly doesn't matter. Okay, 8.42 times 10 to the negative fifth. Negative 5 means I'm going to move 5 to the left. So pick up my decimal and go 1, 2, 3, 4, 5. Lock it in. Fill in your gaps. So I get 0.0000842. One more. I want to take 3.695 times 10 to the negative second. My exponent's negative, so it's telling me to pick it up and move it 2 to the left. 1, 2. Lock it in. Fill in any gaps you made. So 0.03695. I cannot stress this enough. That exponent represents moves. It does not represent zeros. An exponent of 5 doesn't necessarily mean you're going to have 5 zeros. It means your decimal is going to move 5 times. So just be really careful and aware of that. Okay? So what is all this even for? Now, a lot of the examples, actually about all the examples I showed you, I didn't do super, super huge or super, super small numbers. But there are times in life when you're going to have super huge or super small numbers, especially if you go into some sort of career in science. There's a lot of times in science when you have really massive or really tiny numbers. Scientific notation gives us a way to use to work with those really big or really small numbers and a way to represent them that's much easier than having to write all those zeros out. If you have a number that has like 100 zeros after it, and yes, that's possible, you probably don't want to make 100 zeros. Scientific notation makes it to where you don't have to write the whole thing, but you can still convey the meaning. Okie doke. Hopefully that helped. My students, if you need more help, please don't ever be afraid to ask. Reach out. Tell me what I can do for you. There's multiple ways that you know to get a hold of me. If you're not one of my students and you just happen across this video, I hope that you found a use for it and that you feel a little bit better now about scientific notation. I do have a YouTube channel, guys. It's Math with Luger. Sorry, I started to say my classroom Facebook. Math with Luger. Feel free to subscribe. They're all 7th grade standards with a few 8th grade mixed in, since I also teach the 7th grade advanced class. Thank you so much. Until next time. Bye-bye.